use your graphing calculator to solve probability problems, such as the ones in Chapter 5. So I am going to start with the example 9 from Chapter 5. And example 9 starts off with, we want to find the area to the right of z equals 1.78. So in our graphing calculator, we start with the lower bound and then we put in the upper bound. In a z-score, the mean is 0 and the standard deviation is 1, so we don't have to put that in. So we're going to hit our second vars, go down to normal CDF, and my lower bound will be 1.78. My upper bound will be positive infinity, and I represent that with just a bunch of 9s. And my area then is 0.0375. So that's example 9. Example 10, we want the area of the curve to the left of 1.35. So if here's 0, 1.35 of a z-score would be over here, and we want everything to the left. So my answer should be above 0.5. Again, I'm going to hit second vars, go down to normal CDF, but this time I am going to start with negative infinity as my lower bound because we're reading from left to right. So I'm going to start with negative, enter, negative infinity, just negative and a bunch of 9s. Let me see if I can zoom out a little bit here. Comma 1.35 and enter, and there's my probability. So now in example 11 they're asking us to find the z-score less than 1.49. Again, if I draw my little drawing, 1.49 is going to be over here and I want it less than. So second vars down to normal CDF. I'm going to start with my negative infinity as my lower bound. Negative 99999, comma 1.49. And there's my area. 12 is a greater than, so we want z greater than negative 2.31. So my lower bound is negative 2.31. Second vars, normal CDF, negative 2.31, comma 9999, enter. And there's my area. So now in example 13, they give us 2 points. So they give us the lower bound of negative 2.14 and the upper bound of 0.95. So when I go to my normal CDF, second vars, second vars, normal CDF. I'm going to type in my lower bound of negative 2.14, comma my upper bound of 0.95, enter. And there is my probability, my area, my proportion. They interchange all of those words. So now I'm going to do the visualization of the normal curve example. They want to know what percent of all SAT scores are below 680. They give us a mu of 500 and a standard deviation of 100. So second, bars, normal CDF. So they want it to the left, so I'm going to start with my negative infinity, comma, my 680, comma, my mu, 500, comma, my standard deviation. Since it's not a z-score anymore, I have to put in my mean and my standard deviation. And I get 0.964, which is 96.4 of all SAT scores are below 680. So in 14A, we want to know the scores, the proportion of scores that fall between 450 and 600. So I'm going to do my second bars, normal CDF, and I'm going to go 450, comma, 600, comma, my mu of 500, comma, my standard deviation of 100. 0.5328, which is 53.28%. So now when we're looking at the z-score in reverse, we're going to use the second var's inverse norm, which is one right below it. So here, the very first number that you put in your calculator has to be a decimal. So if you're given the 90th percentile, the 90th percentile tells you that you're 0.9 and everything below. So all we have to do, if it's a z-score, is put in 0.9 and hit enter. And we get 1.28 is the corresponding z-score to 90% below. Now, if we want the top 10% in 14B, again, we're looking at the 90th percentile below. So I'm going to hit my second bars. I'm not looking for a probability, so I'm not going to use inverse or normal CDF. They're giving me a probability of 10%. 10% would be down here. I want the top 10%. So I have to say I want 90% below it. So I'm going to hit my inverse norm, 0.9. Since I'm not looking for a z-score, I have to type in my mean, comma, my standard deviation, and then hit enter. And a SAT score of 628 would be the top 10%. So that concludes the video. Hope it was helpful.